Okay, let's look at random experiment 2. Okay, now compared to random experiment 1, random experiment 2 is that we flip a bias coin thrice, 3 times. Okay, and we are interested in the number of heads resulting. We are interested in the number of heads resulting. And how biased a coin? Say the probability of getting a head, this is pi, and pi is equal to 1/3. When you flip such a coin, say 300 times, you expect to see 100 heads. If you flip 3,000 times, you expect to see 1,000 heads. Okay? That's what we mean, probability of getting heads is 1/3. Okay? Now, what is a distribution? What is a distribution? We say, what is a PNF? Probability mass function of y. Okay? Now, just like the last example we did, okay? We can either get no heads, 1 head, 2 heads, or 3 heads, and probability of getting those heads, okay? Now, let's work on only one, because the other one follows similarly, okay? What is the probability y equal to 2? Okay? 2 heads. When I make 3 flips, how likely I see 2 heads? This is probability that we see head, head, tail. Or we see head, tail, head. Or we see tail, head, head. Okay? Now, in this case, getting a tail, the chance is 2/3. Okay? Because getting a head is 1/3. And 1 minus 1/3 is 2/3. It's complement. So this one is also 1/3. Okay? Now, similarly, you can argue for this too. Okay? Chance of getting heads is 1/3. And how many heads we see? We see 2 heads. Okay? And chance of getting a tail is 2/3. And we see only 1 tail. And how many such possible sequence here? 3. And how we get the 3? Well, from a combinatorial argument. When you make what? 3 flip. From 3 flip, you choose 2 of them and assign what? Assign heads. So the 3 choose 2. That's why you see what? 3 here. And this is 1/3 to the power 2, 2/3. So this number is 6 out of 27. Okay? Now, by a very similar argument, we can write it one by one. This one is 6 out of 27. And the others, probability y equal to 0. That means we see 3 tails in a row. And chance to see a tail is 2/3. And 3 of them is 2/3 to the power 3. And this number is 8 out of 27. Okay? How about 1? 1 is 12/27. And how about 3 heads in a row? 1/3 to the power 3, which is 1/27. Okay? Now, this is the probability mass function of y. Okay? So if I write it down, if I make a graph here, y And possible value of y, 0, 1, 2, and 3. Okay, 0, 1, 2, and 3. Now, how likely why we see only 3 tails, no heads? That chance is 8 out of 27. Okay, that chance is 8 out of 27. So suppose this is 2, this is 4, this is 2 out of what? 27. This is 4 out of 27. This is 6 out of 27. And this one is 8 out of 27. And this one is 12 out of 27. Y equal to 0 is 8 out of 27. So this is a height. And y equal to 1. Y equal to 1 is 12 out of 27. I think I make a mistake here. This is 10 out of 27, and this is what? This is 12 out of 27, okay? 8 out of 27 is this much. And then 12 out of 27 is this much. And next one, 6 out of 27. And the last one, 1 out of 27. Okay? This is what we call line graph. Line graph. What is a line graph? Line graph is a graphical representation line graph is a graphical representation of P and F of a discrete random variable. Okay, now next one. Let's make a comparison between the P&F of x and P&F of y. So look at here. This is x. And parallel to this one, I put another graph. This is for y. Okay? Now, possible value of x, 0, 1, 2, and 3. Possible value of y is also 0, 1, 2, and 3. Remember, x is resulting from what? Flip a failed coin 3 times. And how many heads we observe? That's x. Y is a number of heads resulting from flipping a biased coin. Okay? Here is a failed coin, pi equal to 50%. Here is a biased coin, pi equal to 1/3. Okay? Now let's compare these two line graphs. One for x, one for y. Now, first one, this is 8 out of 27, and then is what? 12 out of 27. Oh no, this is wrong, right? I think I should change this one to what? X is a failed coin, right? What's a failed coin? Failed coin is a, well, I make a mistake here, okay? I make a mistake here. So let's stop here.